This is a video on work. Work in physics is defined as the transfer of energy to an object by applying a force to that object that causes the motion of that object to change. There's an equation for calculating work. Work is equal to the force that you apply to the object times the distance you move the object. And you're going to end up with units of newtons for force and meters for distance, and a newton meter is a joule, which makes sense because we're transferring energy. We should end up with the same units as energy. They're not always going to give you what the force is. Sometimes you're going to be asked to calculate the force, and you can do that using F equals ma, or you can use the weight formula. Weight is equal to mass times acceleration due to gravity, where acceleration due to gravity is 9.8 meters per second squared. So anytime you get a problem where they don't give you an acceleration, probably going to be 9.8 meters per second squared if it's in the vertical direction. Learning target number 8 is to be able to use the equation to calculate work in joules. And we have a triangle that we can use to help us out with that. Just make sure that you remember to put work on top. Force and distance both go on the bottom. Here's an example. We want to calculate work. We're given a force of 10 newtons. We're given a distance of 3 meters. You can either use the triangle, or you can find somewhere on your quiz or test the formula for work. Work is equal to force times distance, so if you're using the triangle, just cover up the work. And we have work is equal to 10 newtons times 3 meters. Do the math and you get 30 newton meters, and a newton meter is a joule. How much work is done here? It's a little bit trickier. We're given a mass and a height, and we're going to need to calculate the work. We don't know the force. We do get a distance of 1.25 meters, but we're going to have to calculate the force before we can calculate the work. So in order to calculate work, we need force times distance. And in this case, we're going to use F equals ma to get our force. Force is equal to mass of 8.5 kilograms times an acceleration of 9.8 meters per second squared. And that is equal to 83.3 newtons. So if the object weighs 83.3 newtons, that's the amount of force we're going to need to apply to lift that much weight. So when we plug that force into our work equation, we get 83.3 newtons times 1.25 meters, and we get a work value of 104 joules. How much work is done in this case? We have a barbell that has a mass of 250 kilograms, and we have a baby who is 0.5 meters tall. If you use your equation to try to find work, we have a force of 250 kilograms times 9.8 meters per second squared, but we have a distance of 0 meters. So when we use our equation, work is equal to force times distance, our force is 2,450 newtons. We multiply it by a 0 height. Anything we multiply by 0 is going to end up being 0. So we have done 0 work. And again, it's because the barbell does not move. Nothing moves, then there is no work that's done. Doesn't matter how hard you sweat or how much energy you expend. If it doesn't move, you don't do any work. There's a strongman competition. Strongman A has to lift a 1,200 Newton stone onto a pedestal that's 1.5 meters high, and he does it in 10 seconds. Strongman B lifts the same stone to the same height, but does it in 5 seconds. Who does more work, Strongman A or Strongman B? And you can go through and calculate how much work Strongman A and Strongman B do, but in the end, they do the same amount of work because work does not depend on time. The one does it faster than the other, but that doesn't affect how much work they did. Work is just the force times the distance. Here's an example of calculating distance, knowing the amount of work and the amount of force. So instead of being given the force and the distance, this time we're given the work and the force, and we're asked to solve for the distance. Again, we have in our equation, work is force times distance. Remember on your triangle that work goes on the top. In this case, we want to know distance, so we cover up the d, and we have an equation that is d equals work divided by force. Now we just plug numbers in. Distance is equal to 20,000 joules divided by 500 newtons, and we get a distance of 40 meters.